Hello, and welcome
to mythbangerz.
Turn down the weed.
I'm your host, Christian, but you can call me Dinksy Vives. Joining me today is computer scientist Picante and the world's leading thermoastronuclear physicist, Straight Cachomi. We are here to show you that the world isn't as it seems.
Yeah, he's like, you should give him a 0 for it. This is so mean at times. Like
He's always
Hello there.
that's a sad thing.
Let's say we have two balls of equal mass, starting at the same height, h, above the ground. One ball is dropped from rest, while the other is projected forward with a horizontal velocity. Now what if I told you that one ball would hit the ground before the other? This is the myth we're here to disprove. The ball should hit the ground at the exact same time.
If you have two balls of equal mass at the same height, and you throw one of them with a horizontal velocity, and you let the other one drop, which one will hit the floor first?
Well, I believe God chooses one, and I believe that He will choose the one that moves horizontally, because the way to move up is to move forward.
Equal mass at the same height. One you throw with a horizontal velocity, and the other one you drop. Which one will hit the ground first?
I'll say the one you drop.
yeah.
If you have two balls of equal mass and at the same height, and you throw one of them with a horizontal velocity, and you let the other one drop, which one will hit the ground first? The second one, the one that you throw horizontally?
That's how you can do, because that way you
It'll hit the ground first?
It's like, that's it. Christian!
So you have two balls of the same mass at the same height. One of them is thrown with a horizontal velocity, and the other one is dropped. Which one will hit the ground first?
Well, thank you for asking. That's actually a very simple physics problem. If this one is thrown with a horizontal velocity, it will be moving faster. Therefore, it will reach the ground the same distance away in a shorter amount of time.
So this is a myth about kinematics, but in our experiment, we're using the principles of electricity and magnetism to debunk this myth.
That's dumb.
Here we have a circuit with an electromagnet with a 100-gram mass stuck on the bottom. We have wires running around with a tripwire made of paper clips at the end. When another 100-gram mass is thrown horizontally across the table, it will break the tripwire and release the mass under the magnet. They will both be released off the table at the exact same time and will land on the ground at the exact same time. 2, 1, go.
Another one.
1, go.
Oh!
Another one. Another one.
It's late and I'm awake.
mythbangerz slip stock. Smashers for the win.
So you just saw the experiment, and the two masses hit the ground at the exact same time. So let's talk about the physics behind that. Here, we have the paths of the two objects as they're falling towards the ground. One mass thrown horizontally, the other drops straight down. Their paths differ, but the net force on each object is the same. Because they have the same mass, the force of gravity on each object is the same, so they have the same downward acceleration, so they'll hit the ground at the same time. To calculate the time that it takes these objects to hit the ground, we use this kinematic equation up here. And knowing that the initial vertical velocity for each object is 0, we just plug that in and we solve for time t, which is the square root of 2 times g times the height.
Oh, hello there. Now, here at the Mythbangers, we believe in the holistic banging, okay, of myths. To really do that, there's something you haven't heard about yet, and it's called the unit bang. Now, this is a very, very difficult thing to understand, but if we start with a kinematic equation that we had before, delta x equals x naught plus v naught t plus 1/2 at squared, we can replace them with their units. Meters equal meters per second squared times second squared, and you simplify, meters equals meters. That check is the most important part.